Hi everyone, me again. So till now you have seen and understood a lot of things, that how we work on to understand if there is any vulnerability, or how to avoid the to have attack on our ICs by the attacker, or any other kind of malicious activity, right? But what if till now we have worked about the ICs level, that okay, we can go to the nanometer level with the electron beam and remove the material with the ion beam. But how about these printed board circuit, the PCBs? These are not made of silicon, these are printed circuit board made of metal. How we are going to use these ion beams to understand the malicious activity in any of these kinds of circuits? Plus, look at the sizes. The IC is basically just a part of an integrated circuit. You will find an IC over here on which we work with all of these instruments. But look at the size of these ICs. They are much more bigger and have lot of more. This is like there is no component, but how about this one? Can you look at the size? And you can see how many components are over on this. How you are going to understand or determine if any attacker put up a very small malicious component over here, which you don't know about, which was not in your golden circuit layout when you were fabricating this material. How you are going to understand about this? You can't use this inside the chamber of these ion beams or the electron microscope or photon microscope. How you are going to understand this? Plus, all other applications which you have seen, like focused ion beam, okay, or any other failure analysis technique, what exactly they need is they are basically the destructive reverse engineering, because we are basically destroying our sample. We are removing the material, we are digging the hole in this IC, means we are destroying it up. Now we can't use it back. But how about these? We can't do all of this. And so there is another instrument which we have in our lab, which is the X-ray machine. All of you might have, know about the X-ray, especially when we are younger, we play around, so we break a lot of ankles, twist a lot of ankles, so we all have went to the X-ray. Exactly the same concept, but over in this, we can't put up a person, we put these ICs. Okay, so when we are putting these ICs, what exactly it's doing is, first of all, it's a non-destructive reverse engineering. Why? Because I'm just putting up my whole printed circuit boards inside it. I'm not destroying my circuit board. Okay, I'm not going to remove anything from it, or I'm going to add on it, like the other instruments I talked about. That's why it's non-destructive reverse engineering. And what exactly happens is, what exactly the system does. So the advantage of using the system is that it actually scan your whole PCBs with the help of the X-rays. And what it does, like all other instruments, most of them, it gives us an image. When it scans the whole PCBs with the X-ray, it can give us the whole image, which is based off layers present inside this PCB. So if you will see over from here, you can't see any kind of that, it's just one layer looks like. But if I will put it inside the system, okay, I will see that there are a lot of multiple layers inside this, and every multiple layer has its own components, okay, and which we all combinedly, when it's put together, looks like they are all over on the top surface. Okay. But how I'm going to know if any attacker put up any malicious component in my PCB on second or third layer? I can't understand or get any idea from this. This is where this system comes from. What exactly it does is, it gives you the full image of, like the SEM does, but it gives you the full image of all the layers, which you can separate as well inside the software, and you can see all your components over here very clearly. So if there is any kind of malicious activity, or if your PCB is damaged anyhow, you can't see it over here. But these small components you can't see over with your naked eye, but inside this you can actually see it over. This is what exactly it's happening over here. Like in the SEM, you were basically magnifying the IC, a smaller IC which is of almost a micrometer of size. You are magnifying it in such a way that you can actually see it, right? What we do in the camera, right? When we zoom in up, we can see the feature which is very far, pretty near and big. That's what's happening over here. Here also the same thing is happening. I can see all these components over my PCBs very much clearly, so that I can understand that if there is any malicious activity in my PCB or not. Okay, so if you will look closely, this is a PCB. Right here you can see over like this. Now I'm going to show you that how an X-ray image of this PCB looks like. Okay, so if I will move this video, you can see this is the exact same PCB, but what's the difference? Actually it's an X-ray image. So now you will be seeing the components. You can actually see, just one second, you can actually see all of your components pretty clearly. And what it's going to do is it's actually going to show you the 3D view as well. So you can see on the right there is a 3D view, and when I am moving it up, my Z position over there, it's basically showing me every single layer. So if I'm going from the top, first it's showing me all the components which are on the top, the first layer. Then I'm going a little bit down, it's showing me all the components on the second, then on the third, so on. So this is how I can see every single component present in my every single layer in a PCB. This is how the X-ray is being used. The concept is exactly the same like the X-rays in over there. It's just that this is being used for the X-ray of the printed circuit board, the PCBs, and that one is used to put for the X-rays of the human beings. So this is what exactly this X-ray system is all about.